Hi everyone, good to see you here and welcome back after the long Easter. I hope you have a good rest and enjoy your holiday. Today this is our Melbourne Python Meetup in June. Actually, today is a special occasion that we are collaborating with another meetup group, the Python Graph Database Meetup, and with their sponsor Leo4j, and they will also share a talk with us in this in these sessions. So before we start, we will acknowledge the Aboriginal and Torres Strait Islander people as the first people and the traditional owner and custodian of the land and waterways on which we live. We honor and pay our respect to the elderly past, present, and futures. And our Python Meetup group also have a code of conduct that we welcome everyone, regardless of your gender, sex, orientation, disability, physical appearance, or anything. If you want to have the details, you can go to the GitHub for the full list. Also, our community also have presence in the LinkedIn and Mastodon environment. So if you are a user on that application, you are also welcome to join us to collaborate with others, add more people, know more people. And so this will be the agenda for today. We will have two speakers. The first one is Ben. He is a product engineering team lead at Style Education. So he will share a Python sandbox package to us. And after that, for about 30 minutes, we'll have a short break where you can have more food, drinks, and more mingling, networking. And then we will have a second presenter. Samko he is the senior pre-sales solution architect from Leo4j. He is also our representative from the Graph Database Meetup group. And after that, we will have another section called Marketplace, where if your team is or your company is hiring for some talent, you can feel free to share and maybe you can find your teammate here. And after that, we will have more networking and collaboration, and the doors will close at 8. And before we begin, we would like to thank our sponsor. First of all, is Judo Bank to share and let us to use their venue. So would Michael have anything that want to share to the audience?
Hello everyone, I'm glad to see everyone here this evening. I hope you're really going to enjoy the talks tonight. If you haven't heard of Judo Bank is a bank in the SME space trying to disrupt the big four, bringing back the spirit of the relationship banking of the 80s. A little about things that you need to know in case of an emergency. Our fire escape is down over that direction, sort of hidden away. Please follow any instructions from volunteers if given. The toilets are all the way past the elevators on your right. Just a fair warning, they are non-gendered, and we have had the building occasionally lock them up in the past. So if that does happen or you do get locked out, please see myself or one of the other volunteers. And if I could have everyone's help in trying to keep this place clean so we can keep running the event here, that would be very much appreciated. Thank you, and hope you enjoy the talks.
And we also thank AWS for their long-term sponsorship on food and drinks. And last but not least, we want to also invite Leo4j. They are the sponsor for the Graph Database Meetup group, and they are the sponsor for the drinks for today. I would like to invite Ashak, the representative, to say something to us. Yeah.
Hello guys, good evening. So I'm from Leo4j. I'm just a part of the Graph Database. Samko is going to be one of those speakers from Leo4j. Thank you all for coming in for this meetup. Graph databases in general, if you sort of talk about, is sort of a databases where you are querying things for a mutual connection. Let's suppose you want to find a mutual friend, anyone mutually. It's a bit of a it's not like a very big complex thing for us. It's very simple in terms of the pioneers. Neo4j was the first company who started graph database technology, and it's going on pretty well for themselves right now. Probably you can ask more of graph databases to Sanko. He's a solution architect at Neo4j working here. And if you have any other doubts, they can probably network. And one motto for sure is like for both our groups is like to meet a new guy, new friend, new person, and talk about things you don't know, because that's what you're here for, right? Networking. So yes, thanks a lot for that, and thank you so much, guys.
Thank you, John. And again, we are welcome you to join our Slack community. So if you cannot scan the QR code now, just go to me after the talk, or any of the organizer. Yeah, we'll share the QR code to you again. And really last thing from us, we always welcome and want to expand our community. So if you are interested in any of the positions, say organizing the event, you want to sponsor us, you want to become a mentor, or you want to be a mentee, or you just have some ideas for us. So you are welcome to join our team, and also we are welcome to talk to us after the talk or anything. And we want to also invite Bernardi, the organizer of this Meetup group, to share a few things with us.
Thanks, Ian. So just a few words pretty much regarding currently open volunteer positions. So as you see over there, pretty much, as Ian already mentioned, those are positions. I want to put a quick call out as well to mentees. So if you've already been around for the past meetups and also pretty much been around also for hearing the announcements that we've had at the meetups, we've already had mentors pretty much being recruited, pretty much what people kind of like to call out for mentors, and we have already, I think, received a good quota of mentors to kind of like start off with. So pretty much just a very early call out that we will be releasing another form soon for mentees. So pretty much if you are pretty much looking to get mentored about and pretty much in different topics, yeah, pretty much like we'll put out the form. We don't have it ready currently, but it'll be pretty much like put out on both the next meetup and also in the NERD meetup announcement, so please stay tuned for that. But in the meanwhile, if you're interested in volunteering for those positions, or if you kind of like want to put ahead your name early in the ring for being a mentee as well, please do reach out to me, Ian, or any of the organizers here, and yeah, we'll get on the right track. Thanks all.
And without further ado, we will start our first presentation. Please welcome Ben.
I am going to have to set up my laptop, so just give me a moment. Hello, hi, this talk is called Crossing the Streams, How I Made a Python Package with JavaScript Using Dino. I gave this talk 2 weeks ago at Melb.js, where I had to explain all the Python bits. And so this time I'll be giving the talk but explaining all the JavaScript bits. And we're back. I'll try and explain some of the things as we go, but I do weird stuff in my side projects, and so I do want to warn you that the stunts in this talk were performed by professionals, so for your safety, don't attempt to do them yourself. I'm going to switch the adapter because that looks like it's broken. It might just be because it's hanging. If we can just move it over. Okay, we'll see. Okay, cool. This is the kind of stuff that my side projects are held together with. All right, background. So I make this thing called Runo, and what it does is it allows you to run code on your website. So I'm just gonna actually show you what Runo is. So this is my website, runo.dev, and this on the left here, let's make it a bit bigger. Too big. This on the left here is some HTML that you could write if you had Rhino. And this on the right is what that HTML would produce. So I can click run, and this is not going out to the internet, this is all running inside the browser. And I can type my name, Ben, and it will say, "G'day Ben, welcome to Rhino." Oh no. Yeah, let's switch it over. Alright, let's give it half a second. No, this is even worse. More. Oh, is it the other end of the HDMI cable? This worked perfectly before when we tested it. Okay, so it runs in the browser on the right, and I personally think this is very impressive, but you may be thinking, well, I could do that with Pyodide, and you're right, but can you do this with Pyodide? This is now running Ruby, and it works. It all works again in the browser, and it can also run a few other things. QuickJS is like a JavaScript runtime. PHP CGI, you don't need to know about that. Clang is C, and Clang PP is C++. Do we just live with this? Okay, so that is my side project. So my concept was that people keep making LLMs write code. And this seems somewhat dangerous. Who knows what the LLM is doing when it's writing the code? Are you reading the code? Probably not, especially not if you're vibe coding, especially not if you're trying to plug that LLM into a pipeline. So we should sandbox the code. We should put the code in a sandbox. And then I was like, I have a sandbox. I built it. It's called Rhino, but it runs in a browser. It doesn't run outside the browser. So that's a problem. And also those AI people like Python. And I wrote my thing in JavaScript. So maybe I can run Node or something from Python and then the whole thing will work. This is seamless. So my plan was make Rhino run using a JavaScript runtime like Node, something, and then run that from Python. Should we switch back to the other one? Okay, so the question mark, I was chatting on Mastodon to Simon W, and he was interested in this problem being solved. And he had a blog post that suggested using dino-compile to solve this problem. And basically what dino-compile does is it takes a bunch of JavaScript and turns it into a binary. And the way it does that is it just packages all of Dino along with the JavaScript. But then it's a binary. And what's neat about that is then I can compile my JavaScript to a binary. Really, it's just Dino and the JavaScript, but it looks like a seamless single executable. So my plan is now make Rhino run using Dino, compile Rhino to a binary using Dino compile, and then run that from Python. So number one was pretty easy. It turns out if you just write standard JavaScript, it runs anywhere, which is really nice. That's a nice thing about JavaScript. And that's because of this committee. This is more like for the JavaScript audience, but I think this is pretty cool. If you're into JavaScript, the Winter TC, they're kind of like, their job is to make it so that stuff that runs on the web also runs outside the web, which means that you can write stuff for the web and then it runs on servers. So then I built this Rhino CLI, and I'm now going to give a live demo of that. Oh no, secrets. Okay, so I have this CLI, and I can do /Rhino. And this is a CLI for running code in a sandbox environment, powered by Rhino and WASI. And I can go, and now I'm going to need to use multiple hands at once. So I can type in Rhino Python entry stdin, and then this is going to read from stdin the Python program and then execute it. So I'm going to put this between my legs. So I'm printing hello world, and then I'm going to hit Control D to EOF, and then you can see it printed out hello world. Now, there's a much easier way to do that, which is to write echo, and then I'm going to put this between my legs again. Print. Oh, we need to print hello world, and then pipe that. So for people who are unfamiliar with shell, the pipe means take the output from this program and put it into this other program. So now if I do that, it prints out hello world, so it executed the Python, which is pretty cool. But what would be cooler is if I did this. So I have a terminal command called LLM that runs an LLM to write some code. So I'm going to use that to write some Python in a moment. Okay, so let's just see what kind of Python this is going to write. So this is an LLM, and it's writing some Python. Now, unfortunately, it's an LLM, and so it's extremely helpful, and it's outputting stuff like, certainly, if you want to create a simple Python script, which is not going to run. So we need to tell it not to do that. So I'm changing the system prompt to be only output code. And of course, now it will also still output Markdown. So then I say no Markdown. And this time, it'll say, hello Python, looking forward to the meetup, which that's cool. And then we can just pipe that straight into Rhino. Yeah, thank you. I made this. Okay, so it says, hello Bob Python, welcome to the meetup. So notice how it's a different message this time? That was because the LLM wrote it from scratch. And we can get the LLM to write anything, and then we can run it, and we can run it safely. So we could say, write some Python to count to 100. And there we go, it did it. So it counted to 100. And then we could do, we don't have to do Python, we could do C, write some.
No, keep Python, it's funny.
Write some C to calculate the first 10, let's start with 10 primes. Okay, so under the hood, this is actually, it's going to ingest that C and then compile it and then run it, which is pretty wild, and it did, and that looks right, probably. Yeah, thank you. Does anyone have a program they wanted to write? No? Okay, well we'll do another live demo in a moment, so we can get back to it. All right, so that was the thing. So now we have step 3, run that from Python, which started off super promising. So I have a CLI, so all I need to do is async IO, create subprocess exec, run my CLI, say that the stuff is going to come over stdin, and then output JSON. And then just pipe it all in, like it. Basically, this is just executing a command from the shell. But it's not hard. But then the hard part was build a package so I can release it to PyPy. PP? How do you say that? PyP? PyPy? Anyway, this took some time. So steps to build a Python package for multiple operating systems. This is the stuff you get that the Melbourne JS group don't get. I'm sure you're so excited. So first off, I set up Hatch to build my binary and then copy it into your package. I do not recommend Hatch. Since then, I've been using UV more, and I would recommend that instead. I wrote a bunch of TOML config. I read lots of documentation. I was tearing my head out, and I found an unrelated issue on the GitHub that gave me a hint about how to write a hatch plugin, and then I ended up getting it working. Additionally, so the real tricky part here is because I'm building a binary, the binary needs to be native for each system I'm running it on. So it needs to be native for macOS, and it also needs to be native for macOS on x86 and on ARM. It needs to be native for Windows, and it needs to be native for every single variant of Linux, of which there's some tricks for doing that, which is called many Linux, and then for ARM and x86. And basically what I did was, cliffhanger, this was I got on GitHub Actions, and I just went commit, 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 commit. Why isn't this working? Why isn't that working? One of the most important steps was giving up on Windows. So it doesn't support Windows. And so the final result is that you can pip install Rano from PyPy, and you can use it in Python. You can do this right now. So this is a script that you could run, and I'm going to do a live demo and run it. So wait, am I? Did I? Yes, I think so. Let's see. Did I put it in here? Yes, I did. Okay. I'm going to type again. So I'm just going to cat that so you can see it. So what this program does is it imports my package, and I've also packaged it with UV. I've written the description dependencies at the top, which UV will run, which is really nice. And then I've got my function hello, and what it does is it uses Ruby to say hello Python, and then it returns that result, and then it prints out what Ruby says. So I have to go talk at the Ruby meetup next. So UV run demo.py, I think that's how you do it. Yeah, Ruby says hello Python. Pretty cool. This is also another chance to applaud. Thank you. Cool. So that's it, sort of working end to end. I think it would be fun if we changed the programming language, did a little bit of just to prove that it's real. So give me a moment. Let's see it happen. Yay! That was really fast. JS says, hello Python, I am JavaScript. Thank you. Where did my presentation go? There it is. Oh yeah, cool. Okay, that was the thing I did. Yeah, so that's me. I'm Ben Taylor. You can find me on Mastodon. The second one is Blue Sky. I'm on LinkedIn. My project's called Rano. That's also me on LinkedIn. I work for Style. Our mission is to provide a world-class science education for every student. We're actively hiring. I'd love to chat to you about that. Any questions?
You said you gave up on Windows. Does it work on WSL?
Sorry, there's a microphone there. Does it work on WSL? Yes, it will work on WSL because WSL is just Ubuntu. So yeah, it will absolutely work on WSL. There's a question off the back there.
I just wanted to thank you for showing examples of Murphy's Law.
Oh, you're welcome. Question at the front.
Really impressive stuff.
Oh, thank you.
Have you tried compiling the Rano to a shared library, like to an SO, then linking it to a...
So unfortunately, because it is JavaScript, I can't provide it as a library unless one of the things that I use can build to a library. So Dino doesn't have that capability. It can only compile it to a shell command. I don't know how to, just a normal binary, not you can't dynamically link into it. It was a pathway that I was interested in. I'd love if someone built that with Dino, that'd be really cool. There's other pathways for getting this to run from Python that are maybe more elegant, but this does seem to work. Yeah.
Can I have a follow-up question? Can you give a few sentences about how Rhino is actually implemented, or the architecture? I saw there's Wasm there, there's Wasim.
Yeah, it's implemented in WebAssembly. We can definitely go deep later, and I've got some blog posts on the website, but basically it's WebAssembly, and the WebAssembly runs using a thing called the WebAssembly System Interface, which is a standard set of binary interfaces that many programming languages can build to target, and effectively it's what Rhino is a operating system that sits on top of WebAssembly and has a custom implementation. And by operating system, I mean in the old school term where it's just system calls for files. So if you understand what that means, then you can chat to me later and if you have more questions.
Any more questions?
So other than printing to stand it out,
Yes.
Is there anything else it can do, potentially?
It can do anything. It's Turing complete. Really, the thing it's most useful for is sandboxing. The thing it's least useful for is running packages that aren't implemented, that aren't packaged with Python or Ruby or anything, which is actually a huge limitation. Because mostly, if you're getting an LLM to run code, you want that LLM to be able to import some other package, like you want it to import like NumPy or something, right? And that won't work. So that's something that Pyodide is way better at. But Pyodide doesn't run Ruby code. So like, if your LLM writes Ruby, I don't know why it is doing that, but if it did, then that wouldn't work. Yeah. So yeah, I think I went off the train of your question. What was the question?
So I'm just trying to think of like a specific use case, right?
Yeah, that's a good question, and me too.
That was what I suspected the answer was.
No, the thing it's really good for is the original use case is it's really good for running code on the web for educational purposes. So for creating examples that you could run in your blog post that people could run directly. The package itself is more targeted at LLM. I'm really interested in turning it into a, what are they called? An MCP? The thing that the LLM runs the tools with. Yeah, so I'm really interested in turning it into that because that would be useful as an MCP. I just haven't had a holiday since the last holiday in January, so I haven't done that yet. I think that's probably enough. You can, okay, we have one last question.
Hey, thanks, man. Just one quick question. It's more about the LLM, the validation part that you were doing. And I was wondering, I assume like while running this, writing this package, I assume you have to use LLM to write a lot of code. In your experience, of which model have you used and which one seems to be working the most accurately, generally?
That's a whole other talk. It changes month by month. Apparently everyone's using Gemini now for code writing. Before that it was the Claude Sonnet, yeah. And honestly, I just use whichever one is right in front of me. So if I'm in the terminal, then I think that's hooked up to ChatGPT. I've got a shortcut for ChatGPT, which is option space, and I use that most of the time. And then my Copilot, I think uses Claude, and I have Gemini in every single one of my Google documents, and it's never been useful once. I think let's wrap it up there. Cool.
Gemini 2.5 Pro is that's great.
Gemini Studio.
So thanks, Bank, for the presentation. So you're welcome to get more pizza, drinks, and more level.
Today, I'm basically going to present what it is to building a recommendation engine using Graph. So Graph database, I don't know how much of you are aware of it. So it's basically a new type of database. And because of its connectivity, it's very easy to run algorithm and then give you the answer such as what is the shortest path from A to B? in recommendation engine, there would be like a customer journey. How long does customer like stay in the website, and where do they journey through, and then like what ends up in purchase, right? All of that and more. And then like what customers are connected to other customers, and what's the purchasing pattern. All of that answers, like you can answer that using Graph database. And because it's a database company, we work with a lot of data engineers and primarily using Python. So we have a lot of Python package you can play with. So I hope that's enough interest for you in the talk. So yeah, quick intro to myself. As I said, my name is Sanko. I started my career as a Java engineer in LG back in South Korea, and then I moved to Australia, and then I worked in an IT consulting firm for about 10 years before I got a job in Neo4j. When I first encountered Neo4j, it was in one of my projects, and I thought it was a very nifty little product. And when they came to me about the job opportunity, I said yes. So I had to take it. So this is the agenda. I'm gonna do a very quick intro of GraphDB, and I'll give you a quick case study of the retail recommendation engine using GraphDB. And then we'll walk through some like hypothetical scenarios of like, let's say we are building something like using for a retailer, and then what process, what types of recommendation approach that you have to take. And then we'll go on to more interesting part, which is I'm hoping that it will work because like it's going to be partially demo. GDS walkthrough and demo. So GDS is the Graph Data Science platform. Within that, you have like 65 to 70 different algorithms you can run just by having data in Graph Database. So I'll show you a couple of examples. Lastly, I'll give you what you can, where you can go for to learn Neo4j. So what is Graph? When you type Graph on Google, this is what you come up. Not exactly the type of graph, not exactly the type of graph that I would imagine, but like people when you ask someone that this is what they think, but when you put in graph theory, now we're actually getting the right place, right? Because graph theory is by connecting your data, you're actually uncovering a lot of different hidden relationships, and then you can infer. You can actually do a lot of complex, ask questions about the very complex relationship. Relational database, unlike the name itself, not exactly relational, it's more columnar store. So it's very hard when you're trying to join, for example, like even 4 or 5 tables, it gets pain in the ass. Not only like talking about just the writing the SQL, the process and the time latency, everything goes like exponentially high. So graph theorem itself was started by, 1736? It was first founded by Euler. So based on this like little math problem that people were actually challenging themselves for. It's called 7 Bridges of the Königsberg Problem. It's one of the city in Russia, if I'm not wrong. And that's what it looked like on the map. So there are 7 bridges that connecting different islands of the city together. And then somebody asked questions like, oh, can you cross all 7 bridges without crossing one more than one time, right? So like you can only cross the bridges 1 time each, and can you go through everything, single thing? So they're mathematicians are trying to answer the problem. Like how do we do that? Like they're trying to like a lot of different ways, like brute force kind of like testing. But then brilliant scientist, mathematician, a scholar, Euler has come up with a new theorem, basically representing each island as a node and then bridge as a edge or relationship to prove the fact that it can be done. So that's your answer. It can't do, yeah.
Did you say
cannot? You cannot. So you're bound to cross at least 1 bridge more than once. So you don't have to kill yourself over like over tonight. So now, how many of you have heard about Neo4j here? Oh wow, okay. Almost half, that's great. So Neo4j is the first graph database company, founded about 14, 15 years ago. So it's been around quite a while, but in Australian market, it's still relatively new. We don't have a lot of like massive use cases or companies, even though we do work with a lot of big companies. A lot of the engineers are still quite new to it. But we do have massive community, and for a graph database company, we are the biggest one because we are the first founder. And then, as you can see, eBay, Levi's, NASA, and UBS, there are a lot of like big logos that we are using, but I'm not here to sell you the product. So we'll go on to the knowledge graph. So, knowledge graph is basically representing the real life data in nodes and edges. Nodes mean the entity, it represents the entity and object. Edge would be the relationship, kind of descriptive knowledge information about different data points. You would usually, probably you're used to seeing the data in tables and the columns. But this way, not only it is very intuitive and very instinctive, you immediately understand what's going on. Like you don't have to trying to like read the ERD diagrams. Like where's the customer and where do they live? Oh, in this table. So none of that happens. Everything is stored exactly as is. So that's the best part. So I'll probably touch that on a little bit later as well. But we don't do index lookup. All the traversing is like point-to-point traversal. So when you're thinking about like joining or hopping like between 20 or 50 or 100 different data points, everything happens in the milliseconds, like a very linear way, not exponentially increasing just because you're joining 10 more tables. And Google is also using knowledge graph like for their search engine. When you type in certain things, then for example, you're typing Sagrada Familia, and then on the right side of panel, you'll see the knowledge panel, right? So it's kind of like a new feature with the Google. So when you type in certain person or a certain place, it actually gives you contextual information around it, not just about the person or the place itself. It gives you all the relevant information. That's because it was powered by the knowledge graph. So knowledge graph puts context into your data. You have your structured data. Think of it just like a relational database, representing the data that like very well formatted. And then you have a lot of documents that you want to connect to the graph, to connect to the structured data. So you would position it like it's a very simplistic way to connecting unstructured to structured. You have customer product documents, and document will have a lot of different unstructured text format, which would be represented by the text itself, and then we'll chunk it for the vector embeddings. And then you will also extract some of the entities and relationship out of the documents, so you have more additional context about the data itself. So when you ask questions, you're not only asking about the data itself, you're asking about the context of the document, but you're not stopping there like the vector database. You're actually traversing out back to more contextual information. So when you ask questions like, oh, who managed the contract with the Neo4j? And it's not just going to give you the people who's mentioned within the contract. Vector database is just going to do that. But we want to know who manages this contract. So you traverse upward to the document storage, and then traverse to the team who manages it, and go down to the people, and then it can actually give you more accurate information. So I'm kind of like verging into more like graph rag talk here. Just wanted to give you a bit of a sprinkle, but that's the knowledge graph. So as I mentioned, just very quickly, because we have something called index-free adjacency, meaning that we are not looking up index when we traverse through data to that data point. All the relationship itself is a first-class citizen, meaning that relationship is written with the node along with the data itself. So it might be a little bit heavier on the right side, but when it comes to reading, you don't have to look up anything, you don't have to join anything. Everything happens very quick in linear way. So when you have a very small graph, you're not going to see any difference. What you're going to see difference is like once you have a very complex question that you have to join 10 tables or 20 tables, and then you have billions of records, then you're immediately going to see the impact of the latency performance that graph can provide. Using RDBMS, you're going to have a nightmare. It's not only that, you're also going to have a nightmare maintaining the data itself. Whereas in graph, it's also a NoSQL database, so you can actually organically grow out the schema, and then it kind of scales out really well. So that's where a lot of complex use cases now living on the graph. So let's say, go through the basic components. We have nodes that represents the entity in the graph, and relationship. So we have a person that knows each other, lives with person, and then someone drives, and someone owns the car. All of that is relationship. And Neo4j is a property graph. So meaning that each of the nodes, and not only nodes, the relationship itself can contain properties. So you can see on the node, name, born, Twitter, all of that is like part of the property. But because the reason why these two have different properties, because like I said, it's NoSQL, it's a schema-less, so you don't really have to abide by like specific schema, so it can grow up organically as your business grows. And then you can have a property on the relationship itself. And if I were to compare that to relational database where everybody's used to, so rows would become nodes, and join tables would become the relationship, and table name is the node label, and columns would become the property of node or relationship. This is very straightforward one-to-one mapping, how you can convert your data to graph. However, because you would realize once you have your data in the graph, oh, it's not exactly one-to-one. The funny thing is, like, a lot of data engineers, not just data engineers, everybody who thinks with their human brain, like, they don't think in tables, rows, and columns. They immediately, when I ask you to, for example, like, oh, give me, write me how, like, your friend's relationship, for example, or like, where do you live? You would draw out, oh, like, my friend Andrew here, and then I have been friend, like, since somewhere, and then, like, you know, he lives here, and then I was living here before. So you don't start writing the tables, right? So your brain is already thinking in graph and very organically, and then you don't have to, like, but everybody's trying to convert that into table first. And then, you know, now everybody's have to unlearn some of the things they have learned and then trying to put it back into the graph form. So that's where a lot of people are a little bit confused. But once you have, like, convert that and then start asking questions in graph, you immediately realize, oh, there's a better way to do it. And some connectors and integration points you can do. We have a lot of different accelerators, especially for Python. We have, like, not only, like, all the other languages supported, but Python driver has the most feature. Not only that, we also have different Python, actually that's on the next page. Yes, these are all the Python libraries that are officially supported and then, like, quite widely used within the community. So the first DB operation, you have default Python driver and a GDS, that's for graph data science algorithm. And you have Spark connector for, like, a massive bulk ingestion. You know, Python driver might be a little bit limited to if you were to ingest the billions and billions of record into the graph. So Spark connectors tend to be often used. Visualization, this is actually funny, because that NeoVis is initially a Java library, so now it's repackaged as a Python library, so something similar to, I guess, what Ben did. But I don't think actually we did a great job, because I've tested myself, there's some limitation, but there's a better visualization tool with Neo4j called Bloom and Explorer, but this is just for you to, like, you know, visualize the concept within the notebook. So obviously I don't think anybody is writing Python to write front end, so. And then we have GenAI partnership with LangChain and Llama. That's why we have those libraries that immediately you can use those to trigger all the LangChain Llama features as well as a new feature within single library. And then we have Graph Record Library, which is a whole another talk, so I'm not going to get into that. And these are some popular graph use cases. We have real-time recommendation, which I'm going to do a little bit of today. And then these are some of the famous companies and brands that have been using that for that use case. And then we have fraud detection, which is one of my favorite, because I'm a big fan of the crime investigation show. You know, whenever you see those detectives, you see those, like, push pin, and then they're putting the strings against, literally creating the graph of, like, trying to detect the pattern, like, oh, who's actually behind, who's the mastermind of all this, right? So literally a lot of finance industries and banks and, you know, like, even federal police, FBI, they're actually have been known to use the graph to actually identify those patterns. And not to mention, there are a lot of different use cases, like a natural operation, master data, but these are not really interesting, so I'm just going to skip over that. Case study. I'm just going to have a sip of water before which I actually. All right, so there are a lot of different types of recommendations, and then we have product recommendation, as you would know when you go on the website. Oh, like, shit, how did they know, like, that I wanted this? Like, you know, all those kind of recommendation. And the promotion, I was just talking to my friend, and then now Instagram is showing me the ad. I was like, oh, that's freaky. So that's the promotion recommendation. And then logistics and delivery. This is more interesting, probably more like, actually not interesting, more boring side, but for me it's more interesting. Basically, when they're delivering a route, logistics, you know, whenever there's a road disruption, which happens a lot in Melbourne, you need to immediately find an alternate route, and then you need to also find a very efficient way to navigate through. So all of that pathfinding is, like, you know, done really well within the graph using a lot of different algorithms. So those are different types of recommendations, but we're going to get into product recommendation real quick. I'm just going to check the time. What time is it? Okay, I think I'm okay. So Walmart is one of the biggest example that we have who's using the product recommendation, using Neo4j for product recommendation. Everybody have used, I don't think actually, no, now that I think about it, this is American brand, so. So yeah, but their challenge is like not unlike any other retailers. When the customer comes in, we want to recommend products that are relevant to them, not just because they're popular, right? Depending on the demographics or what they have purchased before, maybe you might be interested in this. Or somebody like you have purchased this, like you might want to look into that. All of that product recommendation, they want to basically drive up the sale. Money, money, money. Now they create the product knowledge graph using their products. So they have a lot of furniture, for example, let's start with furniture. And you have furniture node, and then you have tags that represents its attributes. So you have physical attributes such as a brown color, a living room, leather, material, couch, foam, and then you have your abstract tags like a modern style, kid-friendly, it's easy to assemble. All of the tag is going to contribute to the fact that like, do I want to recommend this to this client, to this customer or not? And then all of that would also be kind of connected to each other from the order, from the purchase pattern, from the viewing, from like by adding to the basket. Or even like the product itself would have a hierarchy, they have a class, they have different category of products, right? So all of that is like intertwined within the graph. And it's really hard to visualize, not only visualize, just to find the relevant product to recommend using the table. This is one of the examples, like very small subgraph that I took out. So let's start with Jane. So Jane logged on session number 138, and then she checked light fixture, light bulb, and light fixture, and then she purchased them, right? And then she purchased these two together because, like, when you buy a light bulb, you're not gonna just buy a light bulb. You need to attach that to somewhere. So you have a fixture. That's inferred. That inferred relationship is called a purchase with, and when you go there, it belongs to the same brand, which is a very similar product. And then you go onto the fixture, and somebody Mingo have also purchased this fixture, but he didn't purchase that light. What we can do, we can recommend that light because they're purchased with this fixture, or we can also recommend the light bulb because they are similar in terms of the fact that they belong to the same brand, right? And then let's go back to Mingo, and Mingo is very similar to Aditi. That could be the fact that maybe their demographics are similar, maybe they're similar age, same gender, or maybe they live in the same area, or maybe they have been purchasing a lot of similar things in the past. Whatever it is, we know they are similar to. And now we can use that information to recommend a lot of different stuff to Aditi as well. So this is kind of like a quick examples of how you can use the graph to infer relationship, use the complicated graph to make sense of your data and then drive the revenue. Not only that, customer journey. Journey is also a path, and then you have Jane logged onto the session, and the next session, and you see the pattern, and then like each session there is a different cluster of data that is coming through. And then when you see this pattern, and then she ends up buying this stuff, when you see the same pattern, similar pattern happening in different customer, for example, even before they get to the next step, we've seen a lot of people like going to this page next or that cluster of product next. So we can use that information to recommend. All right, that's all the case studies, boring stuff out of it. Okay, let's just do some fun exercise. So now I'm hiring all of you to build a recommendation engine. So you're given a very simplistic data. We have customer data that has demographic information. We have browsing history, user session, views, purchase, add to cart, whatnot. And we have product data, product name, brand, price, event, seasonal, sales data. So what do? You need to start connecting the data, right? There are a few things to consider when it comes to recommending a product. It doesn't just come to, this is not just about the product, the recommendation in general, like, whether or not it's a product recommendation, promotion, or different types of logistic path recommendation. There are a lot of things to consider. The yellow one on the top, beige one, product information is very simple. Like this is what most of the retailers are using. They use the popularity to drive sales, like to recommend stuff. And seasonality, event promotion, very straightforward stuff, not really relational. However, when you come to these three clouds here, thought cloud, customer demographics, you can use that information to drive sales, but like right now, this is all disconnected. And then you have customer behavior. You have engagement events like a purchasing events and viewing add to cart, and how often they come back, when's the last time they came here, what are these like preferences like. Some customers like to buy a lot of brand, like good brand stuff. Some people like to buy like cheap stuff. There's a lot of different preferences that you can consider too, like when it comes to recommending. And then lastly, collaborative filtering. That's where the fun starts, and that's where I'm gonna quickly show you the Python code, like how you can use the very simple, literally maybe like 10 lines of code to run the collaborative filtering. So we're gonna put all that into the graph and connect them. This is a bit wordy, I apologize for that. This is something that I've been working on, because I currently have 2 customers who are going through the product, not product, just the recommendation engine, building recommendation engine. They have a lot of different approaches, like, not everything is by the book. I'm going through a lot of pain right now, because customers like to do one thing over the other, even though like clearly there's there are other things like a low-hanging fruit that you can go for, but our business wants to do this now. So anyway, enough of my complaining. So these are a level of recommendation steps you can do. As lower you go, the higher the degree of personalization is. So the first one, no personalization at all, like what everybody does, trending products. Oh, these are popular, you might want to buy that. It's like, yeah, but I don't really have, yeah. Anyway, complementary products. So that's a little bit more fun, not necessarily related to the people itself, but it's related to the product itself. So when, for example, the example that I showed you earlier, like light fixture and light bulb tends to be purchased together. When I purchase the Christmas tree, I'm gonna buy ornament and the lights. There are things that kind of like go together, right? And these are the complementary products. Like that's based on the number of statistics, number of data. Like it's like, oh, well, like who purchased these 2 together the most? And then that's the complementary data. And similar products, now they are more about, it depends on how you define similarity. But when you have data in graph, you can generate something called node embeddings. So that is, everybody's aware of, I assume, like text embeddings or graph image embedding, audio embedding. So node embedding is essentially the same thing, but it represents the subgraph. So it represents the connection that each of the node has. So if I have a relationship with Jane and Austin, and then some other person also knows Jane and Austin, and me and that person has a very similar node embeddings because we know the same people. And then depends on the property of the node, property of the relationship, everything becomes the vector representation. So using that to identify which are the actually similar products, even though they belong to the different category, could be a thing that you can actually use to recommend. And now, from number 4, 5, 6, that's where real personalization happens. So affinity-based recommendation based on what I purchased in the past. So that's the algorithm, right? I purchased a lot of, for example, like black and green furniture for my house. So that I have a very specific affinity towards the color of the product, and then that's the thing you can actually use, like based on what person has done in the past, to use to drive to the next sales. And peer-based recommendation, similar. Instead of generating node embeddings on the product, you can generate the node embeddings on the person. If me and Dan are the same age, I assume, then we have, and then we are both male, living in Melbourne, similar node embeddings than I would have with, for example, Stella, right? So, that's a very straightforward, easy way. But if she has bought a lot of things that I bought, then maybe we are closer than I know, right? So that's the kind of thing that people similar to you have purchased this stuff. You might want to have a look into that. And lastly, community-driven recommendation. This is a little bit more advanced level. So along with a lot of different algorithms that we offer in Neo4j, there's a few things called community detection. Basically, identifying the cluster of nodes that are relevant to each other, and then within that cluster, you can make a different recommendation. So this is based on the people, product, who you're connected to. So connectivity has to be very high to leverage the number 6. All right, collaborative filtering, I've mentioned briefly. So this is what a lot of the retailer and everybody basically who are using the building recommendation engine is focusing on right now. So collaborative filtering meaning that you're not driving the data from one single spot, one single data source. Everybody, like everything they're doing on the platform, is contributing towards each other and helping each other. Help them find the filter out some a finer data, an actual data that matters to them. Everybody's kind of so it's think of it as like, you know, contributing to a Wikipedia page. Probably not the best example because like you can mess with it. But yeah, like it's based on the massive bulk of data. So that's actually where its real meaning comes from. As I've shown, as I told you, pure-based recommendation, based on these two customers have purchased the same product and they live in the same area, meaning that even though customer A have never purchased product 3, because customer, this is supposed to be B, sorry, typo, because these two are similar, I'm going to recommend product 3 to that person. Same thing with the complementary product. These customers have purchased A1 and 2 before, right? And then so this one and that one have been purchased often together, so product 2 is complementary. So if customer only purchased product 1, I'm going to recommend product 2 because they're complementary, based on the data. And these are no similarity. I don't think I need to like walk through. Basically, Bob, Alice, like they all like different element, different instrument. Based on that, we're calculating the similarity. So you can see Bob and Alice have a very high similarity because they both like guitar and synthesizer, but because Alice likes bongos as well, you know, like it's not exactly quite one, right? So there is a logic how it's calculated, and there's also weighted calculation called the card method. If you're interested, you can go to Graph Data Science webpage that I can send you the link. That there's a lot of different algorithms, but like it's very geeky, and I'm not going to touch on every single thing. What I want to show you, I'm sorry. These are all the Graph Data Science algorithms. So you have path finding, where is the shortest path, or the alternate path, and then centrality, like who's the center of this connection. That is really integral for example, like fraud detection. You might want to, for example, if you want to find like who's running the money laundering ring, you know, oftentimes like you're not gonna, you know, like even the people who do a lot of work like Money Mule, they might be connected to a lot of different people, but that themselves is not behind like mastermind, right? So you need to find who's actually connected to those hypernode, like we call the hypernode, the one that's connected to a lot of different fraudulent activities. But what you really want to find out is who have the higher connectivity to those hypernodes. So that's called like betweenness centrality. So, you know, like this is one of the algorithms you can run to identify immediately, oh, this is a person who's connected to a lot of the major issues. Then you can kind of use that algorithm to like identify. It's very interesting. Maybe I'll do the fraud talk next. Community detection, as I mentioned, link prediction, similarity, graph embeddings. I'm gonna stick to the very simple example and then go with the graph embeddings as code examples. So let's jump to this. Okay, before I show that, so that's basically the data that I'm right now running. You have class, customer, inventory, product data. So it's very similar to what I've explained to you. We have customer data, we have product data, and then we have like purchasing data. Ignore the co-purchasing right now, we're gonna regenerate that. So what you can do, so I'll start with I think I already ran this, but let's see if I can run it again. So start with pip install. We are installing Neo4j, Python driver, Graph Data Science, PyArrow, and then Neo4j Viz, and Pandas. And please don't take a picture of that. Oh, actually, I'm gonna. If you've done, it's fine. I'm gonna destroy it anyway. So yeah, that's the password. I'm gonna access the Neo4j database now. All right, so you can see very easy, stereotypical. It's not using any other technique than like, you know, like for you to connect to, for example, like MongoDB or Cosmos, like it's same situation. So we're connection established, and then I ran a very quick query. So this is actually a Cypher query. If you can see, that's the language that we use. So we don't use SQL, we use Cypher. And now there is a new ISO standard for graph query language called GQL. You know, funny because like ISO community, they call themselves community of standards, but they ever only standardized like SQL. After 40 years later, they finally standardized another language called GQL, which is largely based on Cypher. And then you can see how easy it is to understand. So you have customer is now, it's just like a large arrow. So customer is either purchasing, viewing, or adding to cart a product that has attribute. We're just asking that path. And when I run that, because I've already run that, there's a lot of remnants of, yeah, there you go. So you can see there are 3 products that share a lot of attributes that's purchased by this customer. And when you go to Bloom, which is our out-of-the-box visualization tool, there's a lot better way you can interact with it right now. Unfortunately, everything is labeled product and attribute. You have no idea what it is, which is a problem. I tried to go around it, but I don't think there is actually a feature that you can kind of put the caption on it. There are some other library that I found that is not officially supported, but oftentimes, those who are developed by the brilliant Ben is actually better than the one that's supported by the full company. So there are a lot of different resources. But that's basically how it looks. And now what I'm gonna do is I'm gonna connect to the graph data science. And when you connect to graph data science, there's a lot of algorithms you can run. And then one of the things that I'm gonna run today is called FastRP. FastRP is like one of the graph embedding algorithm. So basically what I'm gonna do is create a co-purchasing pattern. So we have a lot of different products. And then I want to know which are the complementary products, right? So right now, only data that we have, is like, oh, customer purchasing a product and some other product and viewing the product, but I don't want to know which products are purchased often together, right? So what I'm doing here, this is just cleaning up, because I already created co-purchasing before today, so I'm just going to delete everything. So as you can see here, it took really. That's 5 seconds to delete all the co-purchasing relationship that product has to another product. And this is what I'm gonna run. So you can see on the cipher, product, customer is purchasing a product, P1, and then purchasing another product, P2. When you write it like that, we don't traverse the same route twice. So it means that these two are not intertwined and not overlapping each other. So if you think of that as in SQL, you're self-joining the product. And then we're now connecting that to product with the co-purchasing relationship. We're projecting that onto in-memory graph. And then we have a base memory, and then now I've projected the new memory, a new subgraph of these two co-purchasing patterns. Now we have that information. I want to persist that. Not only persist that, because right now if I just write it back to the graph, it's going to be really messy because there's a lot of co-purchasing. I want to know which are the highly connected, right? So which one are frequently purchased. So now that I have graph, I'm going to generate node embeddings based on that. So because I have that subgraph, I'm only generating embeddings based on the product entities and that co-purchasing relationship. If I am purchased, if light bulb is purchased with the light fixture, and then there's another light bulb or decoration that purchased together, those two are highly connected, and then they'll probably have, if you were to score that, normalize the score, they would have a higher score than light fixture and the toilet brush, right? Unless you want to do something with that, I have no idea what people are into. And then you have FastRP, so that's the node graph algorithm. So we are GDS FastRP algorithm to mutate, basically writing. That embedding, and that embedding, co-purchase embedding, is written back to the in-memory projection. But I actually want to persist that and maybe do something about it later. So I'm gonna write co-purchase embedding into the graph itself. So now this is the part where I'm actually writing back to the real graph. Now we have the embedding of the product that based on the purchasing pattern, right? Remember? And now what I want to know is, I don't want every single thing. I just want to know what is the KNN, K nearest neighbor, what are the closest product to each other based on this embedding. So in this context, the closer they are together, the meaning that they have more common purchasing pattern between the product. So that's how we're actually generating use KNN stats. And we have how many relationships been written? About 167,000 relationships. Yeah, that's been written. How long did it take? 12 seconds, right? So all the relationships generated. You've seen me running that, and now I'm gonna jump back to the graph, and let's show me the co-purchasing. It's probably gonna show the same thing. Let's see, one of the examples. So this is, what is it? Christmas fairy light. All right. It's bought with ornamental storage box. Makes sense. It's also bought with Christmas tree storage bag. Yeah, that makes perfect sense. Royal Deluxe, I have no idea what that is. Christmas light up and Diamante Cube mask. You get the point, right? And you have, when you click the co-purchasing score, then you have your score here that like, oh, the degree of like correlation to each other. And I actually written something later. Okay, let's run that one again. Let's say I am, can you read that text? Okay, so what I'm asking is, oh, let's say you're on the website and I'm looking for portable stick hand blenders because I'm into baking, whatever. And then show me everything that's purchased along with, so you know, your complementary products, right? So based on that, and then I just want to rank it based on the score, and then show me everything that's related to it. Let's just add another layer here. Has class. I want to see what class they belong to. And class. Yeah, let's run that, and then I'll add. It's hard to type with one hand. Class name. All right, let's see. So along with the blender, I have no idea why people buy toys with the blender. Maybe it's because mom, they have kids. And then there are more typical things like oven gloves purchased with it, and you have storage jar sets. Yeah, makes sense. And then some ornament stand and pillow protectors. Again, as you can see, not everything is highly relevant. The reason why is, this is actually one of the real customer data, which I should probably not be showing too much now. But the bottom line is, there are some quality issues, as you can see. The problem with that, the reason why we have the quality issue right now is because we're not considering the recency and the frequency, and then some of the orders that are purchased together. We are going back on a full history of this purchasing. So somebody might have purchased a Christmas tree in Christmas time, and now they're looking for an Easter Bunny product. And then, but these are not purchased together. So I wouldn't recommend the Easter Bunny chocolate to someone who's purchasing a Christmas tree, right? So because there's a seasonality, there's a time sensitive. Right now, our customer is not really including that in. So it's my job to convince them to see the value, like how they can accurately predict and everything using this node embedding. What the bottom is, you see how easy it was, like few lines of code to run the whole like co-purchasing pattern, run the analysis. That's what you can do with the Python package. And if you want to know more about it, there's a Graph Academy, fully free website. All the courses are like hands-on and very well educated. And then you can certify yourself like for free. And then when you get certified, you can get they'll ship you a free T-shirt, which is actually pretty good quality. It's not that. It's really not that. No, it's actually pretty. It's not hideous like that. I don't know why. We don't have the image of that. I was actually gonna wear that today, I forgot. But yeah, and then there's also GDS algorithm certificate. And if you're more into GenAI, and then there's a deep learning AI website that also offers collaboratively with Neo4j that offers the GraphVec pattern class. So have a look at it, and that's me. And lastly, that's the LinkedIn. I already put it in the front, but that's my LinkedIn if you want to get connected with me and ask me any question, or because I didn't really put anything on the GitHub. So if you want to see if you want to get the code snippet, just send me a message. I'm happy to publish. Thank you.
Do anyone have a quick questions for Suko?
Yeah. Oh, a quick question? Well, should I apologize in advance then? This was going to be very early in your slides. You gave a use case, and one of the things you mentioned was RDBMS couldn't hack it.
Yeah.
So the implication there is that there was some kind of data migration between the RDBMS and GraphDB. What, I guess, does that look like?
Yeah, that's a very good question. Right now, a lot of customers are asking this very much the same question. We don't ask them to put everything onto. Can everybody hear me?
Yep. So it depends on the type of problem you want to solve. In this case, Walmart, like they did actually port out like a large amount of the product data onto the graph, but they still kept a lot of the data to like in a warehouse and then whatever they usually store. If the data is highly connected and then you want the complex question, then those data needs to be ported to the graph. And some banks, for example, they want to find the lineage between the data, but like that doesn't mean that every single data has to be in graph like that. But because like lineage is about the relationship question, where does it flow to? Like who does it impact, right? All of that semantic layer. So we are only extracting metadata of each of the database, putting it into the graph. So really becomes what answer you want, right? So. Well.
In terms of server compute, how much more expensive is this to run compared to a normal relational database?
That's a very good question.
I need to know so I can sell it to my CEO.
Oh yeah. I mean, send me a message, mate. Yeah, but it is. I'll say this is not as like cheap because like there's a lot of computing, there's a lot of different algorithms running on top of it. Having said that, there is a different tiers of like licensing. So there's a free tier, like fully available on GCP, and then there's a professional developer tier. Just development level, but we don't recommend that for production. And then we have a business critical, which is eligible for production, but it's like if you have a very sensitive data, like banks, then you might want to go on to enterprise license. So there's like 4 different levels: free, professional, business critical, and the enterprise. You only need to contact the sales from the business critical and above. Up to professional, you can just sign up in any hyperscaler, AWS, GCP, Azure.
Yeah, we're medical, so if you want to drop a promo code on the way out, I'll be.
Yeah, my LinkedIn is the promo code. I'll make sure that I get you the deal. I'll take one more question. Yeah.
How would it be to import from Wikipedia to play around?
Oh, that's a very good question. So there is a tool called Graph Builder. So you can type Neo4j Graph Builder, and then it's like a browser tool. So you basically have to just drop a link or PDF, CSV, any unstructured file, right? And then or link. Even YouTube link works if it has a caption. Then you drop there. Unfortunately, I cannot show you today, but it's a really nice product. And it automatically generates a knowledge graph out of it automatically for you. Obviously, you can guide it to be more accurate, like providing more schema, or you can run the duplication process. There's a lot of different things. Bottom line is, it takes a few minutes for you to create a graph, and then it comes with a nice little chatbot, so you can ask about the data you just put.
So would it be like gigabytes or not triple store?
Oh yeah, okay. Triple store is actually a lot easier to convert because it's already in the format of graph. Yeah. But property graph is actually, in triple you have like a subject and a predicate, and then object, and subject object is not really different in graph. Like it just becomes a node, and the predicate becomes the edge, the relationship. So there are tools called RDF library, and then there are tools called neo-semantics that you can just run it through to convert all of that into the graph immediately. Yeah. I think that's. I do have to rush up. I apologize. Thanks, guys.
Thanks again for Sam for his interactive presentation, and again the Graph Database, Meetup, and UJS for their support today. So now we are coming. So I think that's it. So this will wrap up today's meeting. We still have around 10 minutes left before the door will close. So before you leave, please remember to join our Slack channel. Thank you.